Before we start the tutorial, I just want to say thank you to Quixel, who've been kind enough to share some of their code for PivotPainter 2 with us, which made it a lot easier to create the tool and generalize it for any sort of use case. Hi everyone, my name is Paul Bozeson, and today I'm going to show you the new update to the PivotPainter tools that we have in SideFX Labs. So what is PivotPainter and why should you be interested in this? Well, we have a couple of examples and reasons why we should be interested in this here inside of Unreal. So let's say you have a tree like this, which either has a lot of wind applied to it or not a lot of wind applied to it, or a simple example like that, or you're a really big fan of Fortnite and you love the sort of building effect that they have. Those are examples of where you would want to use PivotPainter. Another one such example is, any sorts of visual effects, or for example, grass that is interactive, where if you walk through it, it will, bend away from the player. So how would you do this with Unreal or any other engine? Well, what you do is either rig a tree and have a skeletal-based animation applied to it, or you do this through a shader. With the skeletal approach, the problem is that you're going to have a skeleton for the tree, and that has a lot of CPU overhead, and it can be fairly expensive if you're going to need to make one bone per, let's say, leaf or per branch, or for the entire tree, right? That's going to be very expensive. So what you want to do instead is do it through a shader. You can make wind effects through a shader, and then apply vertex offsets or wheel position offsets to these vertices to make it appear as if the geometry is moving. Because if we look at the object when we click on it, we can see that it is a actual static mesh. It's not a skeletal mesh. So there is no animation or rig living on this piece of geometry. So how does it work? Well, what the tool does, or this approach with the shader-based system, is that for every single sub piece of geometry, right, and with sub piece I mean a part of a hierarchy, we essentially store what the pivot of that object is and what the forward axis of that is. So if we look at this tree here, which has a trunk, it has a branch and then another branch and then leaves at the end, this trunk would have its pivot right here, where we see that. This branch here would have its pivot right here in the middle, and then these guys would have the pivots on here. However, since this is just one piece of geometry and it has one pivot, that information is not stored on the geometry. So what we can do is we can make use of vertex colors, UV channels, and textures to encode this information, and then decode that information in the shader and apply our logic to that. So if we dive inside of the shader, which I will open in right now, let me just drag this over to the other screen. We can see that it makes use of this PivotPainter 2 foliage shader node, and other than that, there's nothing really here except a few colors and just normal pointing in the Z direction or up direction. And then if we open the material instance, we can see that we have a bunch of parameters exposed. We have position and index texture, and X vector and X extent texture, and a bunch of other settings about wind. So that is one of the approaches, and the other one is a approach using only vertex colors and UV channels without any textures. So enough of the game engine for now. Let's take a look at Houdini itself and how we could generate this sort of geometry. So if you've seen the other tutorials of PivotPainter 1, the system of that still works the same in terms of how you set it up, except for a small few little tweaks. And I want to go over those with you because they are rather important for the effect to work. So to create this cool looking star example that we had, I'm just going to use a box. I'm going to UV flatten that. So this is an important step. We need to make sure that our geometry has UVs. We then just create a simple sphere. And we're not really interested in a sphere, but we're interested in the points of the sphere, because I'm going to copy these boxes onto the points. So what I do is I first generate some normals, which you can then visualize like that. We create an attribute called name, and that is just going to have the value set to the point number. So as you can see, our points have point numbers, so we have 86 and 87 and 89. My name attribute is just going to be that number. I then copy my geometry onto those points, and they will be pointing out towards those normals that we saw earlier. Important in this example is that the copy SOP automatically copied the name attribute from the pivots onto the geometry, which is an important step. We need to make sure that the pivots that we have, right, which are these guys here, share a name attribute with the geometry that belongs to that pivot, right? So if we want our geometry to live on these pivots, this piece of geometry, which is now in wireframe, needs to have the same name attribute as this point here. So once again, recap, the geometry needs to have a name attribute and a UV attribute, and the points need to have a matching name attribute and a normal attribute. We then drop down a Unreal PivotPainter node, which will give us an interface like this. By default, when you drop it down, PivotPainter 2 will be selected. This is the modern approach of this. But since in this case we're going to be using PivotPainter 1 for this example, I just set the mode to be PivotPainter 1. Then a major difference between this version of the tool and the previous one is that you no longer need to scale up the geometry by 100 times, right, to make it Unreal scale. This is now handled by the tool itself. So the only thing you really need to do is set the asset name. What do you want the FBX to be named? So in this case, I just called it Boxstar, the folder that you want it to be exported to, and then of course the settings for the type of PivotPainter data that you want to encode. So in this case, since we just care about a pivot per object, there's no sort of hierarchy in here. It's set to per object, which just uses these default values unless you change the packing method to be custom. However, that is for advanced users, so I won't really cover that in this video. Once we have that, all we just really need to do is select our node, and then if we set the display flag on this node here and focus on it, we can see that it is indeed Unreal scale. So it scaled it up 100 times to go from meters to centimeters, which is what Unreal uses. So then what I'm going to do is quickly delete the temporary files that I made before the tutorial so that you can see I have this empty folder. I then click on export, and then what we should be getting here inside of the folder is, as you can see, an FBX file that has the name Boxstar, which is this asset name that we saw here. So let's go into Unreal and see if we can get this thing working inside of the engine. So let's drag and drop our Boxstar object into the engine. And then let's take a look at the import settings, because these are very important. Otherwise, you might be getting weird looking results. So important, vertex color input options, set it to be replace. Then the other thing that we need to take a look at is import our normals, right? We want to use the actual normals that we have. We want to convert our scene, and we do not want to create a material unless, of course, you have very specific reasons to that. I'm going to keep the import scale to 1 as well, because we've already scaled it inside of the PivotPainter tool itself. So click import, and we're going to get this no smoothing group information was found in the FBX scene. That's something that's always going to be there because Houdini does not use smoothing groups. So those are fine to ignore. Drag it into our editor, and we can see that we did have that sphere object. So how do we get this thing to look cool? Well, as you can see, I am using the content examples project files from what Epic ships. And in there, we're going to see a lot of really cool stuff. So there is a maps folder in here. And in that maps folder, there is a folder called, or a level called PivotPainter and PivotPainter 2. So since we use PivotPainter 1 for this object, I'm going to load the PivotPainter scene itself. And as you can see, this is the examples that I've used in the older version of the tool itself. So all we really need to do is just find our geometry that we just imported, which is in my demo folder, drag that into the scene, and then just click any object that already lives here. Click on the scale per object pivot, click on our newly imported object, and then just assign that. And then we can see that it is indeed correctly scaling. To verify that all the pivot and axes settings are also coming through correctly, I'm going to find one that actually rotates the object around its pivot, and just assign that as well, and we can see that yes, indeed, it does work and rotates perfectly fine. There's other examples in here, but I won't really cover those because the primary focus of this tutorial is going to be the PivotPainter 2 example. So PivotPainter 2, the difference between PivotPainter 1 and PivotPainter 2 is that PivotPainter 1 uses just UVs and vertex colors like I mentioned earlier, but PivotPainter 2 uses textures to encode this information. So why would you be using textures for this approach instead of just vertex colors and UVs like I said? Well, that is because textures can store a lot more information a lot more efficiently. So instead of creating tons of UV channels to store hierarchy information, there is some intelligent math that is done by Jonathan Lindquist, who built PivotPainter for Unreal, to encode as much information as possible into these textures. So how do you set up a scene for PivotPainter 2? Well, to take an easy example first, I'm going to show you this this box wall that I have. Let me just disable the template flag, which I want to be basically get constructed through the shader, similar to the sort of building effect that you see in Fortnite, right? Where it puts down a brick and another one and another one and another one. So how do you set that up? First thing, what I do is I just create 2 lines, right? I just have a line and another line, and I offset them a little bit. And these points have point numbers assigned to them as well. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I then use a copy sub to basically just copy it a couple of times. So in this case, I copied it 3 times. I'm going to have 3 copies. And as you can see, they're nicely ordered from 0 to the max here, which is 29. I then, once again, do the similar trick. But in this case, instead of using name to encode or pivot's information, I use hierarchy. And hierarchy is the attribute that is being used by PivotPainter 2 to encode the information. And the way that that needs to look like is just use root and then a slash and then the object name. So in this case, my objects are just going to be called 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But if you want to have more levels of hierarchy, it would of course be root and then, for example, branch 1 and then slash and then leaf 2, etc., right? So we're going to see that in a more complicated example in a little bit. So then, once again, I use a copy to point sub where that hierarchy attribute gets transferred. So as you can see, I have my bricks here. And if I were to look at the spreadsheet, we can see that those indeed did get the hierarchy attribute, came across properly from the pivots. So it had inherited it. Next up, I'm going to be creating an index, which is going to be called selection index. This is another attribute that PivotPainter 2 is looking for a specific mode, right? So in this case, if we set our texture mode to be selection order, we're going to need a selection index. Then, of course, similar to the other PivotPainter, our pivots need to have a normal. In this case, they're just very boring. They just point towards the x-axis because my wall is aligned like that, right? So I just want them to be perpendicular to the wall itself. Then what we do is we drop down PivotPainter node again, and we set the mode to be PivotPainter 2. We give our asset name an actual name. So in this case, I just call it brick wall. We set our output directory, and that's when we then finally get to these textures. So these 2 textures are textures that are being used by PivotPainter itself. And these menus that you see here determine what type of information gets encoded in each of the channels, right? The RGBA channels. So by default, you're going to see that PivotPainter, let me just create the correct one, that PivotPainter uses pivot position and parent index and x vector and extent divided by 2048 by 2048 max. The ones that you're going to need highly depends on what you want to do with PivotPainter. So in this case, since I want to basically drop down objects in a specific order, I encode the selection order into the alpha channel. And that selection order, like I said, is just going to be that index, right, of 0, 1, 2, 3, the order of the bricks that I want to be created. Then for the second texture, I encode the x vector, and that's basically going to be the forward axis, right? So in this case, that is the normal that I encoded on those pivots that we saw earlier. And then a random 0 to 1 value per element. So this is just going to give some random value between 0 to 1 for each of the objects that we see here. Once we're done with that, I just click export, and then if we look at our export folder, we're going to see 3 files being generated. We have our brick wall FBX folder, file, and we have 2 textures. We have a brick wall, which contains the pivot position in the RGB channel and the selection order in this float in the alpha channel. It also tells us that the UVs to be used for PivotPainter are UV2. Then for the other texture, we're going to have the RGBA storing the X vector and the alpha channel, the random 0 to 1 value, once again also using the V2 channel of the FBX. And as you can see, it automatically generated that name based on the drop-down selections that you made here. So let's go into Unreal and go back into maps and find that PivotPainter 2 map that we had. All right, we're in the good folder now. Then I'm going to open my demo folder and I'm going to import the 3 files that I got, right? The FBX and the 2 textures. For the FBX import settings, we're going to use the exact same thing that we did for the other one. So I just left it the way that it was from the previous one. And then we're going to see that we have 2 textures imported as well. Before we use any of these textures, we need to change the compression and some other settings, the filter modes. So these textures can be very small. So if you zoom in 1600%, we can see that it's still very small, simply because this texture is 240 by 32 pixels. So we need to make sure that our compression settings are set to HDR. We need to untick sRGB. We don't want any modifications to our colors. And then here under filter, we change it from default to be nearest. This is a very important setting. We can then close it. And let's close this window as well. And we can see that now we have nicely uninterpolated texture values. So there's no blending between pixel values. Then on the other texture, we're going to do the exact same thing. We're going to change the compression settings to be the HDR, untick sRGB if it is not already, and on filter, set it to nearest as well, and just hit save. So now, let's drag in our brick wall here that we have on our object. Just rotate it so that we can nicely see our brick wall. And then, of course, what we need to do is assign a shader to it. So if you know how to create PivotPainter 2 shaders, great, go ahead and do that. But what I'm going to do is nice and easy, and that is, just select one of these examples that have already been made, and then find the shader that's attached to that. And in this case, I just duplicated it, and it's called this birdhouse thing. In this case, our object is not a birdhouse, so I should have renamed that, but I didn't. Then let's open up our shader and assign the correct textures. So since this is an example shader already provided, we can sort of see what the texture names are that are being used here. So in this case, RGB uses the X vector and A uses the random 0 to 1. That is why I selected these values that you see here, because they were used by the example shader. So let's find our texture that we made and just drag and drop that in there, replace the example that's already there. And this other one, as you can see, is the pivot position in RGB and the selection order in the alpha channel. Drag that guy in there, hit apply, and then we should see our object animating inside of the viewport. So as you can see, it started already because it was already playing when we were modifying our textures. But as you can see, the texture or the shader nicely creates this effect that is seen in Fortnite. Let's just have it play from the start so that we can see it all the way, which might take some time because, oh, there we go. So as you can see, it started with point number 1 or 0, 1, 2, 3, 4, 5, 6, 7, whatever that selection index was that we had set here inside of Houdini. Let's take a look at a somewhat more complex example. I want to create this sort of a fractal-like tree, which I am not going to explain how I did it. You can just look at the example file. But if we right-click on our spreadsheet and look at the hierarchy, this is the part that's interesting. We can see that we have root once again, right? Root slash, and then we have generation 1, object 0. We have a ton of those. then that has a child called generation 2, object 0, and then another child called generation 3, object 0, so on and so on, right? So if we scroll down, we're going to see that we have generation 1, object 3, generation 2, object 15, and that basically describes the hierarchy, right? So the root is going to be this here, the trunk. Then the first child is going to be root slash, generation 0, object 1, generation 0, object 2, generation 0, object 3, etc., etc. And then the child of this one is going to have, the string or the hierarchy of this object plus the name of the child. And that just keeps going on and on and on and on until, we've reached all the way to the end. So it can be a very, long hierarchy for an object. Then we're going to need the exact same thing as before, which is a pivot point. So in this case, if we turn on our point visualizers, we can see that we have a point for the root. We have a point for every child object, all the way until we have pivots for all of the objects. And those, once again, have a matching hierarchy attribute. And they also have a normal. And that normal, once again, is just the forward axis, right? So for the trunk, for example, it just points in the direction of the trunk. And for all of the children branches, they also just point in the direction of the branches themselves. For the geometry, same thing. We have our hierarchy attribute. We have our just regular normals for the geometry. And we have our UV attribute. Plug those into the PivotPainter node, geometry on the left, pivot on the right. Change the mode to be PivotPainter 2. Give it a cool name. And in this case, since I want the tree to be growing, right? I want some sort of growing effect where we first have the trunk growing and then the children growing and then the children of the children growing. I want to add a normalized 0 to 1 hierarchy position. Select our node, hit export, take a look at the export folder itself. We can see that we now indeed have a fractal tree and we have a pivot position in RGB and a parent index integer in alpha. And for the other one, we have an RGB holding the X vector and normalized hierarchy position in the alpha channel. Go back into Unreal and import those files. So the FBX and the two textures, drag those in, keep the same import options. Just like that. Might take a little bit because the geometry is quite heavy. There's a lot of vertices in there. So open up our texture. And then once again, change compression to HDR. Turn off sRGB. Change the filter to be nearest. And hit save. And we do the same thing on this guy here. Set the compression settings to be HDR. Turn off sRGB. And under filter, set it to nearest. As we can see, it went from blurry to not blurry, which is what we want. Okay, then let's get our tree object and just drag that into the scene. Find any of the examples that you want to use. In this case, I used a shader that is assigned to this tree, which is here in the middle by default in the content examples. And then find the shader that we need. In this case, it's this hierarchical growth. And then open the shader and assign the correct textures. So in this case, the first slot is looking for that normalized hierarchy position. So just drag and drop that guy in there. And the other one is looking for the second texture. And then once we're done with that, we can see that our tree is nicely growing and, ungrowing, I guess. Based on that normalized hierarchy position. So trunk first, then the children of those children, and so on and so on. So that's that. That's how PivotPainter 2 works. If you want to do cool wind effects, click on one of the example trees that they have there, and just take a look at the textures and see what they are using. So in this case, you can see that one is using pivot position in RGB and parent index in the alpha channel. And for the other texture, it is using the X vector and RGB and the X division 2048 by 2048 in UV channel 2. So that's how you figure out what type of settings you need for PivotPainter here and how you export it and set it up inside of Unreal. And that's it. If you have any questions, feel free to reach out. If you run into issues, just submit them on the bug database. Thank you.